This is ASPure Maths Notes, and we're just starting Unit 9, which is about logs or logarithms. So first of all, our definition then of our law of logs. We know a to the power of x equals y. That's synonymous with, it just means it's the same thing as x equals log to the base a of y. This tends to cause a lot of confusion, but you know what this means. For example, 2 to the power of 4 equals 16. If we change our a here for a 2, so log to the base 2 of 16 gives us then 4. So this effectively means this to what power gives me this. The way I always do it, I always kind of pick a wee example. I know that 10 to the power of 3 is 1,000, and I know that that's always the same as, and write it another way around, log to the base 10 of 1,000 equals 3. And I guess I kind of memorize this and then I can kind of rearrange it whenever I need to. So 10 to what power gives me 1,000, and the answer then is 3. So x is the logarithm of the number y to the base a, i.e. x is the power to which you have to raise the base a to get the number y. Just a wee kind of divergence from this and the graph of e to the x and the graph of ln x. If we deal with it, e is kind of our exponential number, and if we write log to the base e, that's the same as ln, and these two, I guess, are inverses of each other. So e to the x, e is kind of sort of 2.718 in and around there, so it's in between 2 and 3, and if you were to plot the graph, you would end up with this here. With any of those kind of, I guess, exponential graphs where x is the power, it always goes through the point 0.1, and whenever you kind of put in 1, you have that. Stick it in your calculator, you sort of get your 2.78, and we have that. The other one then is the graph of ln x, and so that's log to the base e of x, and that looks then a wee bit like that. And those two graphs then are the inverse of each other. That's maybe 2 ln x, I'm not quite sure, I need to check that. But those graphs are the inverse of each other. If you reflect them in the line y equals x, you would get the other graph. So the line y equals x in this particular one, I think, looks like this here. And then those would kind of reflect, that's not a great drawing of it, but something like that. That's the graph then of ln x. In our next video, we'll take a wee look kind of then at some of the laws of logs.